10 capacitors, each of 1 microfarad, are first connected in parallel and then in series. The ratio of parallel to series connection is. Here in the question it is said that all the capacitors are of equal capacitance. So in this condition, we can write the equivalent capacitance in series connection is C by N, and equivalent capacitance in parallel connection is N into C, where N is the number of capacitors. So here Cp by Cs is Nc divided by C by N, or we will get N square. Here there are 10 capacitors, so N is 10. So 10 into 10 is 100. Option D is the correct one. A proton is initially 1 angstrom from an alpha particle. The work done in moving proton to infinity is. Equation for work done is charge into potential. Since the proton is moving away from the alpha particle, here charge of proton into potential of alpha particle. That we can write charge of proton into potential equation is 1 by 4 pi epsilon 0 q by r, and charge of alpha particle is 2 times that of proton, because we consider alpha particle as helium nucleus He24, and it represents charge. So it is 2 times that of proton. And we can substitute the value. Charge of proton is 1.6 into 10 raised to minus 19. 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. Charge of alpha particle is 2 into that of proton, and distance, that is given as 1 angstrom, or 1 into 10 raised to minus 10. And when you calculate this, you will get 4.6 into 10 raised to minus 18 joule. So option D is the correct one. The potential inside a sphere of radius r varies as V equal to minus P by R, where R is the distance from the center and R is less than equal to R, and B is constant. Charge enclosed by the sphere is. We have equation for potential is 1 by 4 pi epsilon 0 Q divided by R, and it is given that potential is minus V by R. So from this we can find out charge. Charge is minus B into 4 pi epsilon 0. So you will get minus 4 pi epsilon 0 B. That is option C is the correct one. Effective capacitance between A and B is. We have to find out the effective capacitance between E and B. Here 2C capacitors are in series, again 3C capacitors are in series. Effective capacitance in series connection is, for the first one, equation is C by N. Here C is 2C and N is 2. There are two number of capacitors. So we will get C. Here for the other one also, equation is C by N. Here C is given as 3C, N is 3, because 3 number of capacitors are there. So you will get C. And these two combination, this and this, are connected in parallel. In parallel connection, we can write the effective capacitance as the sum of two. So sum of these two, that is C plus C equal to 2C, is the correct answer. Option A is the correct one. A small electric dipole is at the origin and is given by P equal to 0.6 I plus 0.8 J microcoulomb. An electric field exists in the region given by 8 J plus 6 K Newton per coulomb. The external torque to hold the dipole in position is, equation for torque is P cross E, or we can say P sine theta. Here we can find out using determinants, that is I, J, K. P value is given, that is 0.6i, 0.6, and J is 0.8. There is no K value. And for E, there is no I value, so it is 0. And J value is 8, K value is 6. Let us find this I into, we should neglect the row and column containing I and cross multiply the other term, that is 0.8 into 6 minus 8 into 0 minus J into, we should neglect the row and column containing J and cross multiply the other terms, that is 0.6 into 6 minus 0 into 0 plus K into, we should neglect the row and column containing K and cross multiply the other terms, that is 0.6 into 8 minus 0 into 0.8. So you will get I into a 0.8 into 6, that is 4.8. This will become 0 minus J into zero point 0.6 into 6, 3.6. This will become 0 plus K into 0.6 into 8, that is 4.8. This will become 0. So the correct option is option A, that is 4.8i minus 3.6j plus 4.8k. Thank you for watching my channel. All of you please share and subscribe. Thank you.